Audio Jungle. Audio Jungle.
So hello friends, my name is Samir Dokadiya and today I will discuss about some tricky question on the basis of haloalkanes and haloarenes. So first of all, I am giving you the one advice. Chemistry is a mystery. You have to solve this mystery to understand the chemistry. So let's start the video. First of all, you have given this question. The major product formed in the following reaction is. Here you have given a compound. So the reagent is NaCN, sodium cyanide, and DMF is a solvent. But what is the product or what is the answer in this question? Okay, so here you can see that this is the haloalkane also and haloarene also. How? You can see here simply. This is alkyl halide and this portion is haloarene. So remember one thing, that alkyl halide will be more reactive than the haloarene. Okay. So this chlorine and here there is iodine. What will be substituted with this cyanide? Here you can see that alkyl halide is more reactive than aryl halide. So the chlorine will be substituted with the cyanide. So the CH2CN will be the right product or also the right answer. So the right answer will be C. Okay, only chlorine will substitute it with the cyanide. Okay, I hope you understand this concept. Okay, very easy. Okay, so the second question is a solution of minus or levorotatory 1-chloro-1-phenyl-ethane in toluene. Toluene is a solvent. Racemizes slowly in the presence of a small amount of SbCl5 due to the formation of. So what will be the right answer? Radical, carbanion, carbene or carbocation? Let's do it. This is 1-chloro-1-phenyl-ethane. It reacts with the SbCl5. What will happen? This bond will make coordination bond with antimony and you will get SbCl6 minus. So what will be the second product? This carbocation. Okay, this carbocation is planar. Why? Because this is phenyl ring and it is planar, and this carbocation, this carbon is also planar. So the nucleophile can attack from the upward side or from the downside also. Okay, like this. So you will get both racemic mixture. Why? Because this carbocation is planar and the nucleophile can attack from upward side and also from the downside. So you will get the racemic mixture. So the right answer will be C. I hope you understand. So let's move into the next question. You can see here that this is planar. Okay. This is the carbocation, structure of carbocation. It is planar. You can see here. Okay. So the nucleophile can attack from the upward side and also from the downside. Okay. So let's move into the next question. The absolute configuration of following compound is. So for this, you must remember the RS concept, okay, CIP rules. So the configuration is R or S. It depend on the numbering of atom on the basis of atomic number. Okay, so let's solve this question. So we have given a compound like that. Here OH, here CH3 and COOH. So for this, you must remember the concept of RS nomenclature. But first of all, we should remember the chiral carbon. Here this C1, okay, this is C1, this is a C2, and this is C3 and C4. So this 1 and 4 are not chiral carbon, but 2 and 3 are chiral carbon. Why? For this 2, it is connected with the hydrogen, hydroxyl, carboxyl group, and this is the remaining group. You can see here. So C2 is chiral carbon. And C3, for C3, this C3 is connected with the Cl, H, methyl, and this remaining portion. So C2 and C3 are chiral. Okay, chiral carbon. So for C2 and C3, you will get S and R, or also R and S. What will be the right option? Okay, RR, RS, SR, or SS. What will be the right option? First of all, you should remember the concept of, I am giving you a small concept. Okay, what is the concept? If lowest priority number functional group having lowest priority number is placed on the horizontal line then 1, 2 and 3 order, 1, 2, 3 number. If this 1, 2, 3 number is on the direction of clockwise, so for this you should give the S. And if 1, 2, 3 number is anti-clockwise, then you should give the R. First concept. Then the second concept, if lowest priority number, functional group having lowest priority number is on vertical line, then 1, 2, 3 number is 1, 2, 3 number on clockwise, you should give the R. And if 1, 2, 3 number is on anti-clockwise, you should give the S. I hope you understand this concept. Okay, so first of all, we should go to the structure. Here H, hydroxyl, and then here C double bond O, OH. You should remove this pi bond. you should break this pi bond and you should write another oxygen like this according to the CIP rule. If you break the pi bond, you should connect the oxygen atom, same oxygen atom or any atom with the carbon, but the same. Here oxygen, so you should connect the oxygen atom with the carbon. Okay. So first of all, we should consider the RS nomenclature for this C2. Okay. This carbon C2 is connected with the hydroxyl group, carboxyl group, hydrogen, and this remaining portion is here, you can see. Okay. So what happened? First of all, give the number on the basis of atomic number. So first of all, oxygen will be the first. First will be oxygen. Then this carbon, C2 carbon, is connected with this carbon here. And also here, this is carbon. Okay. So in both the side there is carbon. So you should consider the next atom. Next atom means here you can see this carbon have connected with the free oxygen. So you should write like that: oxygen, oxygen, and oxygen. You should arrange them on the basis of atomic number, decreasing order of the atomic number. And for this carbon, you should arrange them like that. First is fluorine, then carbon, then hydrogen. Okay, hydrogen is the last atom because it will be on fourth number, lowest priority number. So you can see here that after the carbon there will be first here oxygen. Okay, and here for this fluorine. So you should give the order like that. Second will be here and third will be here. Then fourth will be hydrogen. I am drawing the structure like that, okay? So you can understand it. One, two, 3 and 4. So this order is like that. You can see it is clockwise direction and H is on horizontal line. So according to the rule, the clockwise direction and H is on horizontal line. So the C2 will be S configuration. Okay, I hope you understand C2 is S. So what will be about this C3 carbon? Okay, the structure is like that. And we should consider the C3. C3 is connected with the chlorine, methyl, hydrogen and this portion. Like that. Okay. So consider this portion also. So first of all, you should give the priority first is 1 to the chlorine. Then you can see that here this carbon is connected with this C2 carbon and this is another carbon. Both the side there is carbon. So you should consider the next atom. This carbon is connected with the first oxygen according to the atomic number first, then carbon and then hydrogen. And this carbon is connected with the 3 hydrogen. So according to the atomic number, this carbon is connected with the first oxygen and this carbon is connected with the hydrogen. So you should give the second to this carbon. and third will be this, and fourth will be this. Okay, I am drawing the structure so you can understand it. First, second, third, and fourth. So the direction will be anti-clockwise, and H is on horizontal line. If H is on horizontal line, or minimum priority order is on horizontal line and anti-clockwise direction for 1, 2, 3, so the C3 will be R, and according to the first, C2 is S. So the right option is 2S and 3R. So what will be the right answer? 2S and 3R. I hope you understand. If you know more about the IRS nomenclature, please write the comment in the comment section. I will make the video on it. Okay. So I hope you understand. Let's go into the next question. Okay. The major product formed in the following reaction is, here you can see this compound. Okay. And you have given NaOMe, sodium methoxide, and methanol. This sodium methoxide is a base, and base will extract the proton from where? Let's solve it. Okay, so OMe minus will extract proton from here, and this bond, first of all, come here, and this bond will break like that. Br will be Br minus. So Br minus will connect with the Na plus, and you will get NaBr. And this H plus will connect with the OMe, and you will get MEOH. So what will be the product? So the right product will be this. What will be the option? So the right option is option number C. I hope you understand very well about that. So next question is, what would be the product formed when 1-bromo 3-chlorocyclobutane reacts with the two equivalents of metallic sodium in dry ether? Okay. So what is the reaction? This is Wood's reaction. Okay. So what will be the right option? 1-bromo 3-chlorocyclobutane reacts with the sodium in dry ether. Let's solve it. 1-bromo, 1, 2, and 3. 3-chloro. Okay. So what happened? You know that Na have 1 electron in its valence shell. Okay. And this bond will, homolytic fission will occur in this bond like that. Okay. You will get Pr radical, and it will react with this Na, and you will get NaPr. And you will get another product Okay, this is free radical. So this free radical again combine with the sodium. Okay, this sodium will attack on this and you will get Na plus. So don't consider this Na plus. This minus or this two electron will attack on this. Here you can see there is chlorine, here also chlorine. So chlorine is leaving group. So this electron will connected with this carbon, chlorine will remove and you will get such type of product. Okay. So what will be the right answer? So the right answer is C. I hope you understand very well about that. So the next question is Ki and acetone undergoes SN2 reaction with each of PQRS. What is the order of the rate of reaction for the PQRS? So all these molecule will undergoes SN2 reaction. And for SN2 reaction, you must know the order. What is the order? For these, first will be CH3. Then primary. Then secondary. And then tertiary. It is the order of reactivity for this methyl primary, secondary and tertiary SN2 reaction. Here you can see first CH3. Then for Q, here this is carbon and this chlorine is connected with the carbon which is secondary. Why? Because this carbon is connected with the 2 carbon like that. Here methyl group is present. Then for this R, this is primary carbon here and this chlorine is attached with this primary carbon. Why? Because it attached with the only 1 carbon here like that. It is primary carbon. And this is tertiary, sorry, here also primary because chlorine is attached with the primary carbon. Okay, here this carbon is connected with the only 1 carbon. So you can see here there is 1 secondary and 2 primary and 1 methyl is present. So first will become methyl. So first will be P. Then what will be the first? You know that this is primary. Okay, first will be, okay, is methyl first, then primary and then secondary Q. I have not considered this primary carbon because there are 2 primary carbon and I have only considered this R. Why? Because this compound have more reactivity. Why? Because here you can see there is carbonyl group is present and this carbonyl will have the capacity to extract the electron cloud from its side. It is electron withdrawing group. Okay, so this chlorine will easily remove from here. Okay, and the reactivity of this compound will be higher due to this electron withdrawing group carbonyl. Okay, so the chlorine will easily remove and the reactivity of S will be very higher than this methyl attached with the chlorine. Okay, so then you can see the S will come first. So the right order is SPRQ and this is P. I hope you understand very well about this concept. Okay, if you like my video, please like it, share it and subscribe to my channel. Thank you.